For the second part of our review, we're going to focus on integrals. So let's evaluate the following integrals. So the first one will be the integral of x squared sine of x cubed. So you might want to pause the video and take a minute to try to compute this integral yourself. We should think about our integration techniques and which one is appropriate here. Here you can use u substitution. So my u would be x cubed, du would be 3x squared. So when I do my u substitution here, I'm going to get a 1/3, which I'll pull out in front. 1/3 the integral of sine of u du. And the antiderivative of sine is minus cosine. So negative 1/3 cosine of u plus c. Don't forget the plus c. And then your final step is to plug back in. Get rid of the u, it'll be negative 1/3 cosine of x cubed plus c. So here we use the technique, we're using u substitution for this one. Let's look at our second integral. So our second integral will be the integral of x ln x dx. Again, you can pause the video if you want, take a minute and try to calculate this integral. Again, we're going to think about our integration techniques, and the integration technique we should use here. We should use integration by parts. So we're going to make this table to help us figure out our integration by parts. We have two parts here in our integral, x and ln of x. Ln of x is always going to go in the u spot. And then we're going to fill in with the derivative and the antiderivative. The derivative of ln of x, 1 over x. The integral of x will be x squared over 2. And now we go across and diagonally down. So the integral of x ln x is equal to, go across, ln of x, x squared over 2, minus the integral, and then the diagonal, x squared over 2 times 1 over x. And now we have no natural log left in our integrals, so I can just simplify this down to minus 1/2 the integral of x. And we know the antiderivative of x, it's x squared over 2, so this would be minus 1/4 x squared plus c. So again, here for this problem, we're going to use integration by parts. Let's look at one final integral. The last one we're going to look at is the integral of sine squared x dx. Now this integral only has trig functions in it. It has sine, and you should probably notice the power here. The power here is even. So when the power is even on this sine, we need to use the following formula. Sine squared, it's 1/2 1 minus cosine x. Cosine of 2x. Double the angle. So we're going to use that identity to help us compute this integral. So I'm going to pull the 1/2 out in front. 1/2, the integral, 1 minus cosine of 2x. And then when we integrate this, you're going to get 1/2 x. And then for this one, you're going to have to do a u substitution here to compute this integral. If you do that u substitution, you would get minus sine of 2x over 2, and again plus c in our answer. Now I do want to mention that it's going to be important that you know the integration techniques. We're not going to use them right away, but there will be a time coming in a few weeks where you will need to know how to compute integrals very well. So you might want to review these at some point. So I've touched on some of them in this video. U substitution. There's integration by parts. There's trig integrals. And then a technique I haven't really touched on in here, which is trig substitution. So again, these are techniques that we aren't going to use right away, but at some point this semester you are going to need to remember these. So you should review them if you don't quite remember these techniques. It might be helpful if you review them.